afternoon. Evan Snowman here for Umughleko, Making a Difference. Today we're looking at the first episode in the statistics topic. It is not a very long topic. There's only really one thing that we need to learn that's specifically new to matric. The rest of it is all effectively revision of grade 11 work. Please remember that there are two key concepts we need to remember, the two measures of central tendency, namely the median and the mean. When it comes to the median, that is the middlemost number when the things are organized, when the data set is organized in order, either ascending or descending order, which means that the data needs to be numerical. The mean is the average. You add up all the values. So again, it needs to be numerical, and you divide by the total number of values, and we can work out the mean. These are the two measures of central tendency. Coming off the median is the idea of the 5-number summary to create 4 zones for us to discuss for more rich conversation or more rich interpretation. We can use a diagram of a box and whiskers, and the key things we want to discuss there are skewness and symmetry. When it comes to the mean, okay, again, so we can create zones for discussion. There is the standard deviation, which must be able to be calculated either by hand or using a calculator, okay, and the idea of skewness comes off that. The next key concept, which becomes more important in matric, is the idea of to extrapolate or to interpolate. So if I was given a data set, let's say a data set with that range. So let's say a minimum value of 12 and a maximum value of 17. If I ask you to make some sort of judgment call about what happened at the number 14, because that is within the data set, that is to interpolate. Okay? So I'm making a judgment call within the data set. Okay? Any judgment call that is being made outside the data set would be to extrapolate. Okay? So that would be to extrapolate. Again, those of you with some language interests would know that inter means inside and extra means outside. So, but again, the closer it is to the data set, the more accurate the reading will be, or the judgment call will be. The further away we go from the data set, the less accurate our judgment call will be. Okay, so we'll see that happening quite a bit in this chapter. But again, for today, what I'm going to do is I'm going to look at doing a fair amount of revision from past papers. This topic is worth 20 marks, of which normally 10 or so marks are given to grade 11 work and 10 or so marks are given to grade 12 work. So let's have a look. Okay, so hopefully we recognize the diagram at the top of the page there. That is a box and whisker diagram. Okay, so what we need to know is that this is the minimum value, this is the Q1, this is the middle value, and this is the Q3, and this here is the maximum value. Okay, so if we were to comment on the skewness of the data, we would say that because they are because these values here, okay, over here, the extra width of this second quartile, these values are lower than expected. Okay, so therefore it is negatively skewed. We'll say it is skewed to the left. Please hope I don't get this wrong. It is negatively skewed, or it is skewed to the left. Okay, write down the range of the marks obtained. Well, we can see that the minimum value, so range, is max minus minimum. The maximum value is 80. The minimum value here is 20. So the range is 60. If the learners had to obtain 32 marks to pass the test, estimate the percentage of the class that failed the test. Well, there is the 32 sitting nicely here at Q1. Now remember, Q1 stands for quartile. So in other words, these are quarters. So in other words, this zone is 25%, this zone is 25%, this zone is 25%, and surprise, surprise, this zone is 25%. Since these people got marks that are higher than the marks, they passed. And since these people did not get the marks required, we can see that therefore 25% of the few students failed, or in this case, did not pass. Oh, they used the word failed, so cool. 25% failed. In ascending order, the second mark is 28. The third mark is 36. The sixth mark is 69. The seventh and eighth marks are the same, so we know that these two are the same. Okay, and the average mark is 54, full of the marks for the learners. Okay, so we know from 1.2 that the minimum value was 20 and the maximum value was 80. We also know from this indication that the median over here is 62. So we therefore know that the middlemost mark is 62. And since there are 9 marks here, 1, 2, 3, 4, 5, 6, 7, 8, 9. Since there are 9 marks here, this value here must be the median. Okay. Now again, because of what we have here, we also know that if we look it through, if this is the median, there are therefore 4 values to the left-hand side. So this value here would be Q1. We can see on the diagram that Q1 is 32 and 32 is the average of 28 and 36. So that makes sense. Well, this will help us answer the right-hand one. That means that these 4 values, when cut in half, provide me with Q3. They tell me that Q3 is 75, but they tell me that these 2 values are the same, which means that these 2 values must be 75 and 75. What we now have is one missing value, and we're going to find out by saying let that value equal to x. Therefore, the sum of these values divided by 9 must equal 54, because that tells us that that is the average. So we're going to add these all up. And so 20 plus 28 plus 36 plus 62 plus 69 plus 75 times 2 plus 80. Write my calculator on, that would help. So 20 plus 28 plus 36 plus 62 plus 69 plus 75 times 2 plus 80. Therefore, 445 plus x over 9 equals 54. So therefore, 445 plus x would equal 54 times 9, which is 486. When I take away the 445, I get an answer of 41. Now, what makes me happy about this value is, yes, 41 seems like a good answer because it does lie in between 36 and 62. It's not the average of those 2 values, but it doesn't need to. We're talking about the numbers listed here in order. And so the x value would need to lie between 36 and 62. The fact that it's 41 doesn't tell me that I'm right, but it tells me that I'm definitely not wrong, and therefore I feel fairly good about this solution. Okay, the second key skill coming out of grade 11 was the ogive curve, also known as the S-curve or the cumulative frequency curve. Okay, so please know that this is also called the S-curve, or it's called the cumulative frequency curve. Okay, and we are being asked to do an interpretation here. They haven't asked us to draw it, so that's the good news, but they're asking us here now to do some readings on it. Okay, so we know that we can see this in 2 different ways. We can see that the growth from 10 to 20 went up by 12. So we know therefore that A must be 12. We can also see that by seeing that the growth from this value to the second marker from 12 to 25 is in fact 13, which we can see over here. The marker here of the value given in the second block was 13. Again, we can see, we can't make sense of it, that the growth from 25 to 45 is 20, given. The growth from 45 to 61 is 16, so B would be 16. And the growth from 61 to 65 is 4, and we can see that over there. So again, even in just taking a gentle reading of the table, we can see that we can find the values of A and B quite easily. Okay. Reading the questions, how many learners visited the tuck shop that day? Well, 65 in total. Okay. What is the modal class? So which class was the most frequent? We can see that the 20 tells us that the modal class is x's between 30 and 40. Okay. Again, let's just quickly write a bit neater than that. X's in between 30 and 40. Okay. Determine the values of A and B. We've done that upstairs. A equaled 12 and B equaled 16. Okay. Use the ODrive to estimate the number of learners who spent at least 45 on the day the data was recorded. So again, we've got to be very careful here that we don't go and just do our own thing. We would go up to 45. Okay. Sorry, 45 Rand. So what am I doing? People who spent 45 Rand. So we'd go to 45 Rand over here, which looks like the halfway point between 40 and 50. We would measure up using and normally indicated with a dotted line. So we'd measure up here until we got to the graph. Okay, and then we'd take our reading off the y-axis. So I'm going a little bit off track here. So it's on the second dot there, so we take it off the second dot. Now, if this is going from 50 to 60, then every block is worth 2. So therefore, the second dot for me would be 54. Okay, so that value is at 54. Now, we've got to be careful we don't answer the question badly. So 45 Rand is marked at 54 people. How many learners spent at least? So we want to have people who are more than that. So therefore, we're going to say that therefore more would be 65 minus 54 equals, not 9, bad maths, equals 11 people. Okay, if they'd asked me, where did I take my reading? Please note, you never take your reading off the actual curve. You take your reading off an axis. So I took my reading off the axis. Okay. Next. Okay. So a couple of comments here. You always take a reading. You only ever take a reading from axis. Okay. And ideally, okay, this is an ODrive curve. Okay. Just we'll see in next week's in the next lesson that we need to be careful when taking a reading from the y-axis onto the x-axis. Okay. But generally speaking, we just need to be careful here. Okay. So there we've revised the ODrive. Excuse me for the hiccup. We revised the ODrive curve. Okay. Please remember, it is simply a cumulative frequency. So all we do is we add up the values. So the 12 plus the 13 made 25. Value we had over here. The 25 plus the 20 made the 45. The value we had over here. The 45 plus the 16 made the value we had over here. We'd plot them. And again, the other name of this curve, the S curve, tells us that we should actually expect a sort of an S. It's not very defined in this case, but there is a very gentle S shape here to this picture as expected. Okay, the final example I have for today is to look at this third example. Okay, and we are looking here at a blood donor clinic. They give us days and units of blood. the mean unit of blood determined over the 10 days. So a mean is simply an average. So we would add them up. Okay, so X bar, so wrong color. Okay, so X bar would equal the sum of all the values over the number of values that tell us that there's 10 people. So there's 10 of them. I'm simply going to add it up. So 45 plus 59 plus 65 plus 73 plus 79, 82, 91, 99, 101, and finally 106. We get exactly 800. Nice value to work with. So the average mark for this class was 80. So they, not class, but in this case, they were able to collect 80 units of blood per day. Okay, the standard deviation of the data. So here, again, we need to know how to use our calculator. And again, I'm going to go through this with you. Okay, so I would go mode stat on my calculator. Okay, I'm assuming that we are using the Casio. I'm sorry if you're using a different brand, but I'm talking about using the Casio at this point in time. Okay, mode stat. Okay, and I'll choose the 1 minus var option. Okay, I would now enter my data. So in this case, 45 equals 59 equals 65 equals 73 equals 79 equals 82 equals 91 equals 99, 101, and finally 106. I know it sounds strange, but I would now type the AC button and I'd apparently clear the screen. All I'm doing is I'm just putting the table into memory. I'll then go to Shift 1, where it says Stat Distribution. Sorry, Z. Shift 1, Stat. Okay, and having done that, I choose the option which says, since I'm looking at variance, I choose the option 4, which says variance. Okay, and over here, I'll choose the one that goes this version of S of X, standard deviation, because that is what we were taught at school, and press equals, and it says to me, the answer is that sigma equals 18,838255, so approximately equal to 18.83 units per day. Okay. In how many days is this units of blood within one standard deviation of the mean? So we know that the mean is 80. And if you were to add 18.583, we'd get 98.83. Okay, so 98.83. So these values are lower, these values are too big. And I don't care about the rounding off. Okay, we're talking about absolutely less than. If I was to subtract that, 80 minus 18.83, I get 61.17. So again, these values are within the realm, and these values are not. So we've got 5 days inside the standard deviation. Okay. They now show it to us as a box and whiskers diagram. Describe the skewness. Again, we've got values that are elongated to the left, okay, which is pulling our mean down. We know where the median is, and these things are pulling the mean to the left, okay? So it is skewed negatively or skewed to the left. I've done the values of A and B, the lower quartile and upper quartile of the data set. Well, the lower quartile, since this has got 10 data points, the median would be between the fifth and sixth values. So there are 5 values to the left of the median, which means that therefore the third one is going to be Q1. And again, third one from the top, in other words, the 8th one is going to be Q3. Okay, so therefore Q1 equals 65 and Q3 equals 99. Okay, so what we're seeing here is that the last 2 chapters of matric work, the ones on probability, which we will look at next, and this one on statistics, don't actually have all that much new material to them, and a large amount of their work is revision of grade 11. And again, in many ways, that means that these topics are slightly lower in cognitive demand. Okay, but that doesn't mean to say that there can't be problem-solving questions in this topic. So be very careful of assuming that this is always going to be easy, even though these questions were fairly straightforward. Sometimes they have some fairly crafty questions in this topic, which again just make you pause and think before you need to commit pen to paper. Okay, the topic for our next chat is on regression lines, and will be a little bit more weighty and thoughtful. Okay. Thank you. All the best.